Hey guys, Mr. B here for the second round of questions from the DBA 2 review. I finished up with number 8, so here's number 9. Which two expressions are equivalent? So think of the word and like an equal sign. Does this thing over here equal this thing over here? So think about the ways that it can be written. 4 plus 3y and 4 plus 3 times y. 3 times y is the same thing as 3y, and you can't combine unlike terms. This has a variable and this one doesn't, so the best you can do is 4 plus 3 times y, which is the same thing here, it's just written a little differently. But you can combine whole numbers, so you can combine what's in the parentheses and get 7, and that's 7 times y, and you can do 7 times y represented as just 7y. So no, these two things on both sides are not equivalent. Those expressions are different. They're not equivalent. Same thing with b. 18 divided by y is the same thing as 18 over y, and you can't add that to 10 because you don't know what y is. Y divided by 18 is the same thing as y over 18, and again, you can't add that to 10. At first, you would go, okay, well, this over here is adding 10, and this over here is also adding 10, but 18 divided by y is not the same thing as y divided by 18. So those are similar, but they are not equivalent. C is equivalent because you are looking at, on this side, y times 2, which is the same thing as 2 times y. Multiplication has the commutative property. It doesn't matter if you have y times 2 or 2 times y. It's the same answer. It doesn't even matter what y is. It's still going to give you the same answer. So you're taking 12 and you're subtracting away 2 times y from it. So 12 minus 2 times y. And you're also subtracting 2 times y away from 12 on this side. So these are equivalent. Down here, 10 minus 6 is 4, and now we're dividing that by y. And over here, the 10 is outside the parentheses, so it's just 6 divided by y, and you're taking that away from 10. So again, you don't have equivalent expressions. One of the best ways to solve this, if you are stuck and you don't know, is to pick a random number for the variable and see if it works. So in our case, for y, let's just choose something real easy. Instead of y, let's choose 1. So 12 minus 1 times 2, and is that equal to 12 minus 2, and instead of y, we're going to put 1. Of course, this is 12 minus 2 after you multiply, and this is also 12 minus 2 after you multiply. So that's going to be 10, and that's going to be 10. So they are equivalent. If you do that with every one of these other examples, if you plug in the number 1, it's not going to be equal after you solve it. So that's how to test and see if expressions are equivalent. Number 10, this is all about reading and understanding what it's saying, okay? So the words give it away. Mr. Smith has a maximum of $50 to spend at a museum. Maximum means that's the most. That is the most he can spend. He cannot spend $50.02. He cannot spend $51. He cannot spend more than 50. But he can spend less. So keep reading. A ticket to the museum costs $7. He can spend P dollars, something, doesn't matter, P, something amount, to buy other things at the museum. Which inequality can be used to find the possible values for P? Okay? Just think about what it's saying. Whatever he spends must be $50 or less. Can he spend 50? Yes, because he has 50. Can he spend less than 50? Of course. He might decide not to spend all of what he has. So he can spend less than or equal to 50. There's only one answer choice that has the inequality less than or equal to 50. So P is the other things he's going to buy, which we don't know what it is. We add that to the cost of the ticket. All of that has to be less than or equal to 50 because that is the maximum he can spend. So I don't even know why you would choose F or G because it's talking about subtracting the price of a ticket. We wouldn't do that. H has the inequality symbol flipped the other way around, saying anything he spends can be 50 or more. No. Maximum means you have to stop at 50. You can't go past it. So hopefully you can use the words to help you solve questions with inequalities. You really do have to read to understand what's going on in math. The most important thing you're going to do in math is read. Number 11 is a conversion question. Mrs. Torres is mailing a package that weighs 12.5 pounds. The post office charges by the ounce to mail a package. How much does the package weigh in ounces? Well, use your formula chart. Your formula chart's going to tell you pretty quickly that there is 16 ounces for every pound. But you don't have 1 pound. You have 12.5. So if you set up a table real quick and say, okay, well, 1 pound is 16 ounces. Another pound is 16 more, which is 32. Another pound is 16 more, which is 48. You find the rule in that table real fast is taking the number of pounds and multiplying it by 16 to give you the number of ounces. So take 12.5 and multiply it by 16 correctly, and that will give you the number of ounces, 200. Use your formula chart when you need to convert between different measurements. Number 12. Adding integers is what this is. A team of 4 players competed in a golf contest. The names and scores of the players on the team are shown on the table. The team's score is the sum, meaning there's addition going on. The sum of all the scores. So add all the scores in the table. So here it is. -2 plus +3 plus -4 plus -1. The sum of all those numbers. We talked about this in class. Here's your 2 negatives. Here's your 3 positives. Here's your 4 negatives. Here's your 1 negative. Okay? Now make 0 pairs. 1 positive and 1 negative is going to make a 0 pair. 1 positive and 1 negative is going to make a 0 pair. 1 positive and 1 negative is going to make a 0 pair. And you're left with -1, -2, -3, -4. Okay? Same thing here. You got 2 negatives, 4 negatives, and 1 negative. That's a total of 7 negatives. You got 3 positives. There they are. 0 pair, 0 pair, 0 pair. You've got 4 negatives left over right there. All right, the sum of all of those is -4. All right, changing a fraction to a percent. A farmer watered 3/8 of a field. What percentage is equivalent to the fraction of the field the farmer watered? Guys, don't make it harder than it is. He watered 3/8 of a field. He didn't water